there's a critical and honestly an often overlooked danger that's just lurking right above our heads. And no, it's not an asteroid, it's not some alien invasion, it's something we put there ourselves, and it really threatens to cut us off from the stars permanently.
And look, that's not the opening line to some new sci-fi blockbuster. That's the terrifying reality of space travel today. We have literally built a cage of high-velocity junk around our own planet, and the walls are closing in. Fast.
I mean, think about it. For decades, we've launched rockets and satellites, and we've basically treated low Earth orbit like it was some infinite cosmic dumping ground. But it's not. It's a finite resource. And right now, the European Space Agency is tracking over 36,000 pieces of debris larger than a softball, all of them setting the stage for a potential catastrophe.
And this whole idea, this fear, it's not actually new. It dates all the way back to 1978. That's when a brilliant but really concerned NASA scientist named Donald Kessler published a paper that, honestly, it sounded less like research and more like a prophecy, a prediction of a disaster that, once it starts, well, it can't be stopped.
And that right there, that's the absolute heart of his theory, what we now call the Kessler syndrome. See, he realized that once you get enough stuff up there, the problem starts to feed itself. It's not just one collision we have to worry about. It's that one collision creating debris that then causes 10 more collisions, and those 10 cause 100 more. It's an exponential nightmare, plain and simple.
And this isn't just some abstract theory anymore. In 2009, step one happened. An active Iridium communications satellite slammed into a defunct Russian Cosmos satellite. That one event, just that one, created over 2,300 new pieces of trackable debris. And every single one of those pieces is now basically a bullet circling the Earth, threatening to cause those secondary collisions, making even more junk until the whole chain reaction makes huge swaths of orbit totally unusable for generations.
Okay, let's dive into this, because to really get why this is so dangerous, you have to understand the incredible physics at play here. You might be thinking, come on, it's a small piece of junk. How bad can it be? Well, the answer is all about one thing: speed.
So, to stay in a stable, low Earth orbit, an object has to be moving at roughly 17,500 miles per hour. That's about 7.8 kilometers a second. It's so fast you could circle the entire planet in just 90 minutes. And at that kind of velocity, the normal rules of physics just get taken to the absolute extreme.
Now, what's so wild about this is how it all comes down to energy. The kinetic energy formula is all about mass times velocity squared. The key here is that velocity is squared, which means speed matters way more than size. So a tiny fleck of paint weighing less than a gram hits with the same destructive force as a bowling ball hurtling down the highway. It could tear through the hull of the International Space Station like it's tissue paper.
So, okay, we've got Kessler's terrifying theory. We've got the insane physics. But why are we focusing so hard on the next couple of years? Why is the clock ticking so much louder right now? Well, it's because after decades of slowly adding to the junk pile, the amount of traffic in low Earth orbit is about to absolutely explode.
And the main reason for this coming traffic jam is something called the mega constellation. We're talking about companies like SpaceX with Starlink or Amazon with Project Cooper. They're launching these massive fleets of thousands of satellites at a time. And while the tech is incredible for global internet, it is also rapidly, and I mean drastically, filling up our orbital highways.
And this chart just illustrates the scale of the challenge perfectly. Just look at that jump. For decades, we had a few thousand active satellites, right? But with companies planning to launch over 50,000 new satellites in the coming years, we're increasing the number of objects by an order of magnitude in less than a decade. We are fundamentally changing the entire orbital environment.
So here's the bottom line. We're not talking about a vast empty space anymore. We're talking about orbital real estate that is quickly turning into a minefield. In fact, just to give you an idea, Starlink satellites alone have had to perform over 25,000 collision avoidance maneuvers in just the last 6 months. Every single new launch just ups the odds of that one mistake, that one collision, that could trigger Kessler's entire cascade.
Okay, so that's the problem. And it's a huge one, which leads us to the biggest question of all. Knowing the risk, what on Earth, or maybe off Earth, can we even do about it? Well, there's a high-stakes race happening right now. A desperate effort by scientists and engineers to figure out how to clean up our own mess before it is truly too late.
And the solutions, well, they sound like they're ripped straight from the pages of a science fiction novel, because the problem itself is just that wild. We're talking about things like ground-based laser brooms that could gently nudge debris out of orbit, or robotic spacecraft that could capture junk in giant nets. There are even ideas for space harpoons to go after massive, dead satellites, like the 8-ton Envisat.
But look, the reality is all of these ideas are incredibly complex, they're incredibly expensive, and they're mostly unproven at any real scale. And that leaves us with this final, really sobering question. Is this all a case of too little too late? Can we invent and deploy these cleanup technologies fast enough, or is humanity destined to become a prisoner on its own planet, locked out of space for centuries by a cage of our very own making?